Hey Sydney, so one of the things that you're missing as you've been gone from class is we've been talking about radioactive decay right here. And so essentially, just to give you a quick little snippet about what radioactive decay is, as you already know by the time you left, if you have an atom and you have a nucleus within that atom, the things that are within the nucleus itself are protons, which are positively charged, and neutrons, which have no charge at all. And so what happens is that in some of the elements, the nucleus is unstable. So if it's unstable, you can kind of think of about that as being unhappy, right? And so if the nucleus is unhappy, it's going to do something in order to get back to a more stable state. And so one of the things it can do is it can change the number of protons it has, it can change the number of neutrons it has. And so I'm going to show you at least two different ways in which atoms do that. And so that process of changing what's happening right here in the nucleus is called radiation. Okay, and so let me take a second here to get rid of this stuff. Let me add a new slide. Okay, so one of the forms of radioactive decay is called alpha decay. Okay, and alpha is represented as the Greek symbol alpha, which is this. It doesn't include the parentheses, but just this right here. Okay, and so what alpha decay means is essentially you have a pretty big atom with a big nucleus, and it has a whole bunch of neutrons and protons in here. And in fact, it has a lot more neutrons and protons, and so it can actually give up some neutrons and protons because it has so many of them. And so what happens is, because it's unstable, it kind of boots out something called an alpha particle. And all an alpha particle is two protons and two neutrons. And so a neutron can be represented as the black circle, and the proton can be represented as the blue circle. Okay, so when I say alpha decay or an alpha particle, this is the alpha particle. So this is the alpha particle itself. Okay, so when something does that, one good example of something doing that is the element radon. Okay, and how you represent that is through something called a nuclear equation. And so radon can go through alpha decay, and this is how. Okay, so one of the things that you're going to kind of have to get familiar with is this whole thing right here is called isotope notation. And so obviously the Ra means that it's the element itself, so radon. The 88 tells us it's the atomic number, so that tells us the amount of protons. And then the 222 tells us the number of protons plus the number of neutrons, or in other words, the mass number. Okay? Now, if you just have this atom, which we're talking about right here, if you had this atom and all of a sudden it just kicks out an alpha particle, in other words, it loses a particle that contains two protons and two neutrons, if this number right here is the number of protons, and I'm telling you that it just lost two protons, then whatever that thing turned into must have, instead of 88, it must have lost its two protons, so it must be down to 86. Okay, fine. Now, since this number right here is the number of protons and neutrons, and I already know it lost two protons, but it also lost two neutrons right here. So if it lost two protons and two neutrons, that's a total of 4. Okay, so in other words, this number, its mass number, should now go down by 4. So all you do is take 222 minus 4, and you end up getting 218. And so how do you know what the heck this new thing is? Is it still radon? Well, it can't be radon still, because in order to be radon, you have to have 88 protons. That's its identification system, right? And so if something has 86 protons, it's a completely new element. It's a completely different thing. So it's almost like radon has like some sort of identity crisis, and then in order to be more stable, it wants to be something else. And so it kicks out 2 protons and 2 neutrons in it, so it turns into something called, I think it's called radium. I'm trying to look up real quick what Rn stands for. So that's the radon, and then the Ra is the radium. So this should be, this should be radium, and therefore this one now is something called radon. Okay, so they're very similar, and I always get them mixed up. So this is radon. So it's just a confusion of names, that's all. Okay, so because it kicked out as 2 protons and 2 neutrons, it lost 2 protons, and it lost a total of 4 right here for its mass number. And so one way you represent that it's gone through alpha decay is you say, look, here's the new, right here is the new element, has this many protons, this many neutrons and protons, and it's this element. And I can tell the reader that it went through a certain sort of radioactive decay, and this type of decay is called alpha decay. As we said earlier, it was represented by this symbol called, it's a Greek letter for alpha, and it represents alpha. And what you do is, up on the top left here, you say 4 because it lost a mass of 4 with 1, 2, 3, 4 right there. And then it has 2 protons in it. Okay, so that's just the notation. So this whole thing all of this right here is one nuclear equation that says, look, at first you had an element of radon, it was unstable, and so in order to go from unstable to a more stable state, it kicked out an alpha particle, and because of that, it now turned into something else. It now has 86 protons, and so it's a whole new element called radon. And oh, by the way, it went through a process known as alpha decay. So that's one form. And so the next video that I send you is going to be on something called beta decay. But this essentially is alpha decay. And so what I'm going to do is I'm going to create a new slide, and I'm going to give you a problem to work on. So let me write it out real quick. If I have, this element's called polonium 208. And it has an atomic number of 84, and it goes through alpha decay and turns into something that you're going to have to figure out. Oops, let me erase this. Alpha 2, 4, and so you have to figure out what this is. Okay, so why don't you go ahead and try that. And maybe in the next video that I send you, I can at least do the answer for this. Okay, so I'll send you another one later.